In this video, I'm reviewing the Adeept 4-wheel drive Mecanum wheels smart car kit for Raspberry Pi. Let's start with quick unboxing. So when you open the box, you have a quick introduction card. And here is the line tracking module. We have an LED matrix. Let me push that over here. We have some for like wiring wrapping, I believe. This is a PCB. I believe it's for the line tracking. We have a couple servos over here. And these are all the screws and all the mounting that you need. It does come with its own tools, so I like that. And it comes with a tiny OLED. Over here, we have a distance sensor. So that's the ultrasonic distance sensor. This is the battery holder, and these are the batteries right here. So I'm going to put these on the side. Let me look and see what's in here. This looks like the Raspberry Pi camera. So let me put that aside. We'll do the assembly here in a second. Just wanted to do a quick unboxing. I believe this is the Raspberry Pi hat, and that is exactly what it is. So this is the main PCB board that connects all the motors and everything and connects to the Raspberry Pi. So this is the robot Raspberry Pi hat. I'm going to do a separate video on this on its own later. So I'm really interested and excited to look into this. All right, let's move on to see what else left in the box. We have the Mecanum wheels right here. We have the motors, the chassis pieces here at the bottom, and then it comes with its own tools. This is the LED RGB module. We have a USB cable, and then it does come with its own tools. So that looks great. Let's go ahead and get started with the assembly. One thing worth mentioning that it comes with a 3 months warranty for the parts, 1 year for the PCB. You can contact them on their website or their email address, which is support@adept.com. There is also a link to a full tutorial, but I will do my best to explain everything in this video, and I will leave everything in the description. By the way, I'm not being paid for this review, so I will just give you my honest opinion. The first step, I got the chassis pieces out, and what we need to do is to peel this wrap. So because they're all wrapped in this paper, so we need to just peel the chassis pieces. So I'm just going to do that first. I've got the chassis pieces cleaned up, and these are all the screws that comes with it and also the tools needed. So let's get started. Let's start the assembly. We start with this piece of the chassis, and we need this M2.5 by 7 screws and the 2.5 by 6 plus 6 copper standoff. So let me take these out. The next step is to add the battery holder. So the opposite of this side, we are going to pass this cable from this square here, and we're going to use these M3 by 10 screws, and we need also M3 nuts. So we're going to use 2 of these. I'm going to put these back, and then here this one screw is going to go this way, and then we'll screw that in place. For this next step, we are going to fix the OLED screen. So this is the OLED screen, and what we are using for this is the M2 screws and the M2 standoff. So we're going to use 4 of them. So let me put this on the side here. I have the screws and the standoffs here. So it is the opposite of the battery side. And you see this here near the square. These are the tiny holes that we're going to use. So I'm going to pass this here. For this next step, we are going to add these. They are M3 by 30 copper standoff, and we are going to use this M3 by 8 screws. They will be facing the battery side. So you see these holes here. We're going to skip this middle one. So we're going to go here. Now we need to add these M3 by 12 standoff, and we're going to use the M3 by 8 screws. These will be on the opposite direction. So let me move these away. And then here, you see these two holes that we left. These will be in the opposite direction of the long ones we just added. So these will be on this side. Now we're going to add these nylon standoff. So you can see these are M3 by 50 nylon standoff. And we are going to use the M3 screws. You probably guessed it. So when we put this on the side, and you see these 4 holes that we left here, and they will be in the direction of the OLED. Now it's time to grab this other part of the chassis and the RGB model, basically the LED lights. And we need these M2 by 10 screws and M2 nuts. So let's go put these on the side. And this is going to be on the side that has the Adeept logo. We're going to put this over here. So like that. Now it's time to put the DC motor mount. They do come with 4 of these. Each one has these mount and these nuts. So let's go ahead and put that on. Now let's mount the motors. I've added the holders here on the side, and I recommend loosen it a little bit so it makes it easier to add the motor here. And let's go ahead and add this one. So you put it here, you use one of these long screws, and they go like so. And then we'll use one of these nuts to keep it in place. And then we have another one from the bottom one here. when you finish mounting the motors, you see the wires on the same side need to match. For example, the black wire up on this side, while the other side need to be the opposite. You can see here the yellow side is up. However, the same side need to match. This is to make sure that you have the motors driving in the same direction and the other side will be the opposite. So basically, because of the way motors spin and we have a DC power, they need to be oriented in that way. Now, the motor itself, you see that there's this like a pointy dot here. This one need to be on the outside, and these motors are on the same side as the logo. So you see here the other side is nothing here, and we have the LEDs right there. Okay, let's put these two pieces together. We will use these M3x8 screws, and we need to also make sure the orientation is correct. So you want to look at this servo place, and it needs to match with this front section, because that's where the head is going to be. So we will pass these wires from here, and then same for the other two wires. And then let's flip this over. We will start tighten things in place. For this next step, we're going to assemble the robot head. So we are adding this piece and a servo. Then we're going to use the M2 screws to put this together. Now for the next step. By the way, we're going to need to align the servo. I will show you that when we turn on the Raspberry Pi. But for now, we're going to use this, the one that is included in the servo. We're going to put it at 180 degree. So be as close as possible to 180 degrees. And again, we have to probably realign this, but for now, this will do. And then using this over here, so we're gonna use an M 2.5 by 7 screw. So let's get one of these first. Put that in the middle here. This next part is we are going to use this other servo to be on top here. So we're gonna rotate that. Let me show you, I just mounted this here. These two screws not needed. I mean, we're probably gonna have to realign this after we turn on the Raspberry Pi, but bear with me for now. This will work. Let's just put that in here. And we're gonna use these M2 by 10 again. And we will just mount this guy right here. Next is going to be the ultrasonic distance sensor. We're going to use the M1.6 by 10 screws and obviously the nuts that comes with it. So we're going to use this part here and we'll put that right there. And then we will pass these through like that. After that, we're going to add the camera module right here. But first, we need to add the 4 screws. We're going to use the same size, the M 1.6. And then first we're gonna put the nut here, so we can just kind of give it a little bit of space. Now we will connect these two together. So this servo, and we will use one of these arms that is included. We will try to get at a 90-degree. So again, we might have to adjust this later after we power on the Raspberry Pi. So I'm gonna try as close as possible for now, and eventually we might have to adjust this. Okay, let's add the LED matrix. So this is the LED matrix, and we're going to use this part over here. We need this 5 screws, M3 by 5, and we need these M3 by 8 copper standoffs. Let's mount this head component onto here, and we will use these M3 screws as well. So these will go over here, and then use this screw here from the side to put that in place. Hopefully that is visible to the camera. There we go. And then we'll do the other side right here. You can move these servos, just be careful with them. I'm going to mount this LED matrix over here. So we left these open. We're gonna do that here. And by the way, these screws are the M3 by 12. So these are the M3 by 12. Here I'm going to add the line tracking module. We need these M3 by 12 screws, and we're gonna go here right by the logo. I'm going to add the light tracking module here at the front, right by the logo. We are going to use these M2 by 10 screws. Before we add the hat, I did mount the Raspberry Pi. This was a little bit more difficult for me to show on camera, but all I did is I added the Raspberry Pi here. And what I did, I connected the camera because the camera will connect to the Raspberry Pi. Make sure you use the port that is a little bit more out of the way because we want this to be on the side so we can add the hat. These are the studs on top here. The standouts are the M2.5 by 21, and we're going to use these screws that are M 2.5 by 7. So now I'm going to add the hat. And again, it's going to sit on top of the Raspberry Pi. Make sure your camera is connected to the Raspberry Pi directly and the cable is out of the way. If you're using a different version of Raspberry Pi, your port might look a little bit different. But this should work with any Raspberry Pi. Yeah, the Raspberry Pi is not included, so you do need to have your own Raspberry Pi. We are going to align the pins and then push this here. And we just need to go ahead and screw it in place. So like that. And I'm just going to put these screws over here. Um, Let me talk a little bit about the wheels. You see they are labeled left, left, right, right. So the position of the wheel need to be intentional. We will look at that when we go over the manual. And they do also come with these couplings. They go over here, and then there is a screw that comes with it, which goes this way here, and then you would screw that onto the DC motor. So this will fit just over the DC motor like so, and then you would screw it on to place. I will show the wiring and how to put the wheels in the right place when we go over the manual. I've just finished putting the wheels on and I want to go over them real quick. So looking from the top, they should form an X. You can see if you draw a line from here to this wheel, then another line from this wheel to this wheel, that is your X. If you flip it over, they should form an O. And if you draw a circle from here to this wheel to this wheel, you get the idea. That is your O from the bottom. So now let's look at the wiring here. And we have our DC motors. So when you have the head forward, this is number 1, 2, 3, and 4. Over here, we have 1, 2, 3, and 4. Our servos, we have servo A, which is the bottom or the first one. Servo B is the top. These are 1 and 2 right here. The camera is connected directly to the Raspberry Pi, so make sure you connect that before you have the hat on top. We have our OLED and RGB connected right here, and we have our distance sensor right here in the middle. This is the power supply, and the LED light or the RGB LED light is right there. We have the line tracking module and the light tracking module connected. So this is the line tracking, and then we have the light tracking over here. So I will show this over the manual, which will make a little bit more sense and hopefully make it easier to understand how you can wire it up. Make sure you make the wiring clean, and I added a zip tie over here. Before we start setting up the Raspberry Pi, I wanted to go to their website. So I went to adept.com and I found the product we are working with. Right now, it is listed on sale for $69.99. And I will leave a link in the description as always. Looking down here, what I really want, there is information about what it does, what components you get, packing list, all these things, the Raspberry Pi hat. But what I'm really interested in here is download tutorial. There is list link here that we can get the tutorial, the code, and the data sheet. So if you download this zip folder, which I just did, and right here in this folder, we get the tutorial, basically how to assemble everything and how everything works. So, but if you are watching this video, then hopefully you can follow along as well. There's the data sheet, which is information about the Raspberry Pi hat, the servo driver, the motor driver, the camera module, all these things in here. And what I'm really interested in is the code. So this is the code that we are going to upload to the Raspberry Pi after we get it set up. Speaking of the tutorial, under chapter 3, lesson 6, they do talk about the wiring on page 32. So let's take a quick look here. We have our Raspberry Pi hat. Here is the battery is connected over here next to the switch. We have our light tracking module goes right there. So right next to this pins, we have our servos. There are two servos, A and B. Servo A is the bottom one, servo B is the top one, and they start here first, 0 and 1. So channel 0 and channel 1. We have our RGB light goes here. Our OLED goes right there. And we have our matrix right next to the OLED. We have our line tracking that goes right there in this connection on its own. We have our ultrasonic distance sensor goes here. And I do also want to mention the DC motors. So if we go up, you can see this is the orientation, and these are the DC motor 1, 2, 3, and 4. So these need to go in order. So if we scroll down, they do go right here on this side. So, and they go 1, 2, 3, and 4. So if we scroll down, you can see these are the DC motors 1, 2, 3, and 4, and they go in that order. If we go up here, this is the orientation. So from the bottom, you can see this is the orientation and the order of the motors. Another thing I do want to mention quickly is by the way, this is the top cover. I'm not gonna put that on just because I still want to maintain access to this for now. So I'm choosing to skip this part, but you're welcome to add this. I do want to scroll down and talk about the wheels here. So you can see the wheels are labeled, and I did discuss this earlier, but I'm just gonna touch base on it really quick here. So these are the wheels. They do come with this attachment, and here you have wheels R, and I mean right and left, and then you have left and right. So they do need to form, let's see here. They do have it written very well here. They do need to form an X if you look at it from the top, and they do need to form an O if you look at it from the bottom. I did explain this earlier, so if you want, you can rewind and see the wheels orientation. Yeah, make sure you wire everything and you have your wheels oriented correctly. Now let's get to the Raspberry Pi and clone the code. I've just logged into my Raspberry Pi, and by the way, for the purpose of this video, I'm going to assume you already have your Raspberry Pi and you can remote into it. If you don't, I have plenty of videos on my channel showing how you can set up your Raspberry Pi and how you can remote desktop into it or access it remotely. I will link to some of these videos in the description, so if you need that, you can watch that separate video, set up your Raspberry Pi so you can remotely access it, then come back here. Again, we're going to assume you already have that set up and you can already remote into your Raspberry Pi. Now, we are going to clone the code. So this first command here, and again, you don't have to memorize anything. You can just copy and paste. I will leave everything for you in the description. So I'm going to copy and paste this first command, and this is the GitHub repository for the Adeept code. So we're going to come here and we will just copy and paste. So after that, hit enter, and this will clone the code into my Raspberry Pi. The next thing here is we need to enable some configuration. You can do this from the command, but you can also do it from the configuration settings. So first, let me show you how you can do this from the UI. You click here and you go under preference. And from here, if you go to the Raspberry Pi configuration, you have this window. And if you go under interface, you see you can enable SSH, you can enable VNC, SPI, and I2C. So this is what we need to enable. So you can do it from here, but also what you can do is you can use this command, which is the sudo raspi-config. So let's do that, and I'll show you how you can enable that from here. So we'll do sudo raspi-config, and then we have this menu. We need to go under 3, and then from here we need to enable this VNC. This one is for the graphical remote desktop access. And we need to enable this SPI and I2C. I've already did that, so mine is already enabled, but if not, you need to click each one of these. They will ask you if you want to enable it. You click yes, then it does the thing, and then you click OK. You go again to number 3, and then you do the same for the SPI, and then you do the same for, so under 3, we're going to do the same for the I2C. And then that's pretty much it. Your Raspberry Pi might need to restart after you confirm this. So we click finish here. It might need to restart if you didn't have them already enabled. Let me clear this. And then the next step is after you enable everything, you have your Raspberry Pi restart if it needs to, and then you've cloned the code. The next is to run the script that will install all the dependent libraries. So I'm going to copy that. And again, you don't need to memorize or anything. I will leave it in the description so you can just copy and paste. So we'll copy this command. We will paste over here. And then this should install the peripherals for the libraries. So let's hit enter. This one might take a while, so I'm going to let it do its thing, and we'll come back when it is completed. Installation is now completed, and I've rebooted the Raspberry Pi. So let's go ahead and run our program. If we go to the code folder here, we have our Adept four-wheel drive smart car. So we're going to open this. I just want to show you the file that we need to run. Under server, we open that, and we have the ordinary wheels and we have the Mecanum wheels. The one we are using right now for this demo is the Mecanum wheels. If you are using the other version, well, you just go to the other code. Right here, if we scroll down, we have this WebServer.python or .py. This is the file we need to run. So I've already got the path. And again, you don't have to remember or memorize anything. I have it written here for you, and I will leave it in the description. So this is to manually run the program just to make sure everything is working. If everything is working, actually, it should run on its own when you power or you turn on the Raspberry Pi. However, if it doesn't, you can manually run it. I do have a separate video. Also, I will leave in the description showing how you can have a program run automatically on start. So all that said, let's go ahead and copy and paste this command. And I'm going to hit enter. This should start running the program, and we can then access it and connect to it. So everything seems to be good here. And if everything is working, then you should see this loop start to work. And by the way, the Raspberry Pi will try to connect to the Wi-Fi that you have. And if it doesn't, then it will just basically start its own hotspot. And the hotspot information is here. So we have the hotspot name, and then you can connect to it basically with your PC or with your laptop, with your phone, and then you can drive it like that. And then I'll show you how to access the page where we can drive everything. But first, we need also to get the IP address. So now everything seems to be working for me. So let me go back here, and I just need to get my Raspberry Pi IP address. I assume you already know this, but if you don't, we're going to show you how to get it. So let me exit out of this. By the way, Control C to stop or to terminate. So let me just do stop equal Control and C. So that's how to stop it. We'll leave that in there. Now let me go back here, and I'm going to use this command, which is the hostname -i to get the IP address. So if we go here, and I'm just going to do hostname I, this will give me my IP address, and you can see here, here's my IP address, the 192.168.0.1.129. This is local to my network. So basically you have to be connected to the same network or to the same internet router to be able to access this. So we'll use this IP address and then the port 5000 to see the page where we can drive this. So let me just do that and show you how that page looks like. Here's a quick look at the UI, which I am very impressed by the way. I was able to access the UI from the IP address, which is the 192.168.0.129. That is my IP address. Obviously, yours is going to be different. That's why you need to know your Raspberry Pi IP address. The port at the end is 5000, so colon 5000. If you connect directly to the Raspberry Pi hotspot, I gave you that information, and I will also leave it in the description. Looking at the UI here, which is very impressive, like I said, very clean, very nice. We have the video, which is the camera feed. Let me see if I can move this guy. And we have the control here where we can drive it, like we can move it. And we have information about the CPU temp, the CPU utilization or usage. We have the RAM. Here is the head control. We have over here the scan for the distance sensor. So very cool here. You have some actions here like uh, different line tracking, light tracking, all these things, which is very nice. So what I'm going to do next is just to show you how the final setup looks like. Then we'll drive it and try some of these actions. Before we test drive it, let's do a final walk around. Right here we have the distance sensor, our camera module, we have our light tracker and our line tracker here at the bottom. Right here is our wheels, and this is the Raspberry Pi hat. I like that you can expand on it. So if you want to develop and add more to this, I'm thinking of adding a LiDAR in the future, something like that. You can definitely expand way more on this. You can power it and charge the battery from a USB-C. If you are going to use this to power it while you're working on it, make sure you turn off the batteries. So you don't want to short those. Be careful with that. Looking here, we have our OLED and our RGB matrix or LED matrix. Let's spin it this way, and you can see our LEDs from the bottom. And looking over here, we have more LEDs on the board. Like I said, this board, I like really the expandability on it, and you can add so much more to the Raspberry Pi. Turning it around this way, and this is pretty much it. I think we talked about everything. Oh, one last thing here, the servos. When you first turn it on, they will go to the middle. So make sure you realign your servos if you need to. Remember, we talked about those earlier when we put the servos and the distance sensor and all that stuff. So when you first power it on, they will go to the middle. You might have to realign. Really simple, just loosen those screws and retighten them in the right position. This is very much it. Now let's go ahead and test out some of the functionalities. Finally, we can drive this thing, and I've been looking so forward to it. Let's look at some of the features. So I'm controlling it from my laptop, and obviously you can drive like forward, backward. You can go to the sides. This is the fun part about having Mecanum wheels. So you can do all these things. And I love the rotation And this is all the functionality that you can do with the Mecanum wheels that you wouldn't be able to do with the regular wheels. Now, let me turn it around. And what I want to show you is the functionality of the head. I'm going to try to zoom in a little bit more. And now I want to show you how you can adjust. So there's a controls where you can move the head. So I can move it up or down. And as I'm doing this, I am looking at the camera feed as well on my laptop. I can go left and right. So that's another thing. And we can also just center this. So this will put it back in position. And remember, we discussed that if your servos are not fully aligned, there's a small adjustment you can do for it. So you can see here, I'm adjusting the head a little bit. So this is a small adjustment to make up for that if you need to. So you can use that. The other piece is we have these lights, for example, the onboard light that we can control. So we can, let's say, turn this function that turn them into a police lights. And yeah, that's pretty cool. There are so much to do here. There is so much control. The other one here is the using the distance sensor to scan the surrounding area. So I'm going to click the scan and it'll do like a scan and show me what's around and the distance of these objects that's around it. So yeah, there are plenty of functionality. I'm going to show you a couple more here in a minute. Let me do one last rotation so you can look at the back. And what I want to show you here is you can see the OLED and the matrix or the LED matrix. So let's see if we can zoom into that. And there you go. So now you can see the OLED in the matrix, which displays information about the battery, the voltage, all that stuff, and then you can control this and make any adjustments that you like. One other functionality I want to highlight is that you can adjust the speed in which you like to drive. For example, you can see here, we can go really slow, or we can go really fast. So I'm going to increase the speed and you will notice a big difference with that. There is a function called keep distance, which is using the distance sensor to keep its distance from a nearby object. Let's test it while it's looking at the wall. So you can see if I put my hand, it backs up. Then when it gets to the wall, it stops there. This next one is automatic drive. Basically, it auto drives randomly while tries its best to avoid objects or obstacles. Let's see how that works. This next one is very cool. We are using the light sensor or the light module to let the robot or the car to follow and track my light. So in the front here, there is a light sensor or a light module, and it's a resistor that changes its value based on the amount of a light that it receives. And using that module, we can definitely tell the car or the robot which direction to go. We're going to use the line tracking module. Let's see how well it does. So I have this line that is supposed to follow, and I do have a curve over here. So let's see how well it does. And you do need enough contrast between the floor and the line so the module can see it. and I think it's doing very well so far. There's so much more to do and learn about this, but I have to wrap it up because I can only make the video so long. However, there will be a follow-up future video, so stay tuned and consider subscribing. In the meantime, if you're interested in learning about robotics, Raspberry Pi, for the price, I think this is a great deal. This is my honest opinion. I'm not being paid to say anything. For now, I will see you in the next one. Thank you for watching.